Welcome back to the RAD Mobile Development Kickstart Mobile Summer School series of lessons here on Developer Direct. This is the 6th lesson in the series, where we'll put together everything you've learned in the first 5 lessons, and we'll also show you how to build powerful multi-tier applications with DataSnap. You can take part in the conversation on Twitter using the hashtag EMBTDD, and you can follow us on EMBTDdirect. If you have any questions after watching these lessons, you can send us email to developerdirect.online@embarcadero.com. So take part in the conversation. It continues even after the lessons are done. This final lesson in the Mobile Summer School series puts together all that you've learned about building mobile applications and combines that knowledge with our DataSnap multi-tier architecture solutions included in the Enterprise Edition of Delphi and RAD Studio XE4. DataSnap is a Delphi technology that allows the development of multi-tier applications, most notably multi-tier database applications. There is also full support for C++ Builder. DataSnap offers the possibility to create client-server applications that communicate through the internet, the local network, or even on a local host. The main feature of DataSnap is the ability of the client application to invoke methods that are implemented on the server. DataSnap automatically generates the necessary interface for the client to communicate with the server, containing the prototypes of the server methods. In this lesson, you'll learn how to connect mobile client applications into your multi-tier infrastructure using DataSnap. DataSnap provides a way for the client to safely communicate with the server using a secure transfer of JSON content over TCP/IP and HTTP. To connect to an enterprise database, you need to have a client library. In most cases, the client library is provided by the database vendor on the platform that you're building clients for. This strategy does not work well for iOS devices because no client library is available for many of the SQL Server databases. To resolve this issue, you can develop a middle tier to connect to an enterprise database, and your iOS application can talk with the middle tier. RAD Studio provides the DataSnap framework in which you can develop the middle tier with almost no coding required. In this lesson, you'll learn how to build a DataSnap server using Delphi, or you could use C++ Builder, that runs on Windows. We'll show you how to build iOS client applications that can use the exposed methods and database access provided by the DataSnap server. We'll also show you how you can connect from other mobile platforms using additional programming languages to connect to your DataSnap servers. Included in the DataSnap support in XE4 are several components that comprise the DataSnap server and give your client applications access to the DataSnap server. Included is the TDSS server component, which allows you to start and stop your DataSnap server. It also has a property called AutoStart to AutoStart your server, or maybe set AutoStart to false and have a timer event to have your DataSnap server activated at a specific time or for a specific period of time. There are on-connect and disconnect events, so you can log connections. And you only need one TDS server component per server application. There's also the TDS server class. The server class is there so that you can control the lifecycle of the connections coming into your DataSnap server from client applications. Lifecycle property values include server, session, and invocation. In the server lifecycle choice, your DataSnap server creates one instance of a server class that is used by all your clients. It's up to your server then to keep track of all the connections, and it needs to be thread safe. The session lifecycle is the default property value, and that means that your DataSnap server will create one instance of a server class for every connected client. And the third choice is invocation, which means that a server class instance is created and destroyed for every method call arriving from a client, and the state of the server class is not preserved between method calls. There are 2 different transports that are available to communicate between the client and the server: the TCP server transport and the HTTP server transport. You can also choose to use HTTPS for more secure transmission of information. On the client side, DataSnap components include the T-SQL connection component, which is based on the DBX framework, where you can specify the driver name, which is DataSnap, and then you can connect to your DataSnap server through either TCP or HTTP or HTTPS, and then right mouse click to generate your DataSnap client classes so that your client application can make method calls and access other information. There's also a T-SQL server method component, which allows you to call server-side methods. And there's a TDS provider connection to get the data and metadata from any database components that you have over in your DataSnap server side to access your SQL databases in your enterprise environment. This Delphi iOS example shows a Delphi iOS client connecting to a remote DataSnap server to access a remote SQL database. This app is a company directory for searching for office phone numbers via a person's name. The backend can be any supported database. For example, in this case, it's using the Interbase Employee GDB database. If you need to create mobile applications for other platforms besides Delphi for iOS, then the DataSnap mobile connector technology is available for using Java on Android, Java on BlackBerry, C# on Windows Phone, and Objective-C for iOS. So now let's take a look at a few different demonstrations of DataSnap technology in action. We'll start first with a quick look at the DataSnap wizard and building your first simple DataSnap server with some methods and building an iOS mobile client. To get us started in the demonstrations, I'm going to use the wizard for DataSnap to build a simple DataSnap server application. And then we'll create a Delphi iOS client application that can talk to the DataSnap server. So we'll say File, New, Other, DataSnap Server. We have our choices. We can choose to build a DataSnap REST application with support for JavaScript and JSON. We can build a DataSnap server, which is an easy way to implement a new server application using DataSnap technology. And our third choice is to build a DataSnap Web Broker application to provide an easy way for a server application that uses both Web Broker and the DataSnap technologies and talks through an HTTP port. We're going to keep this simple to start, and we'll build a DataSnap server. Then we have choices in the wizard, a VCL form application if we want to have a little dashboard display area for our DataSnap server. It could be a console application or a service application. Let's build a VCL form application. Now we have the choices in the next page of the wizard to choose what protocols we want to have supported in our DataSnap server. TCP/IP, HTTP, and HTTPS. We can also choose whether we want to build in authentication and authorization for the client applications that are going to connect to the DataSnap server. We can choose to include some sample methods in our server class. We can also choose whether we want to use some of the built-in filters. We ship a couple of encryption example filters and a compression filter. You can also build your own filters, and there are other filters available out on the internet for DataSnap. What filters do is they take the bytes that are sent from a DataSnap client to a server and from a server to a client and do whatever the filter says. We can choose to create JavaScript files for the interfaces in our server application, or we might want to build a web page or a client mobile using JavaScript application to get to the methods in our server. We can also choose to have the components generated by the wizard to support mobile connector technology for different languages on different mobile platforms. We're going to keep it simple and just create a TCP/IP DataSnap server that has a couple server methods. Then we can choose which port we want our DataSnap servers and clients to talk over. We can test the port to make sure it's okay, or we can click this button to find an open port. The default is port 211, and we'll keep that there. Next, we'll choose the ancestor type for our server methods class. It can either be T-component, T-data module, or T-DataSnap server module. The TDS server module is a data module which has the DataSnap technology and capability for our DataSnap server, as well as a place to put all of our data access components if we were going to do database access. You'll see that in a demonstration a little bit later by Pavel. So let's just keep it simple with a T-component class. Here's the user interface of our application. We can just change the form title, for example, to say My Delphi DataSnap server. We also have the server container unit, which has the DataSnap server component, DSS server. You only need one of those. You can have one or more server classes. We're just going to have one server class. And again, the lifecycle by default is set to session. But we can also choose invocation or server. Since this is simple, we'll leave all the defaults there. And we said we wanted to use the TCP server transport, so it dropped down the right server transport component. If we had chosen TCP and HTTP or HTTPS, we would have then seen two server transport components show up here, one for TCP and one for HTTP. And again, it has the properties, the port that's chosen. We can also set other parameters like the maximum number of threads that are available in session management for the number of clients that are connected. We can have a pool of the sessions that are going on so we don't have to create new threads along the way. And there are other options to specify as well. including there's some event handlers for each of the components, in addition to on-connect and on-disconnect for the DataSnap server. And if we look at the server methods unit, we'll see inside of the name of our server method, which is called tservermethods1, we have two sample methods that are created, one called echoString, which takes a string and returns a string, and another method called reverseString that has input that's a string and will return a string, and then the implementation of those two server methods. So that's all we need in our simple DataSnap server. We can run this server application, and we get this firewall warning on Windows to say that this application is trying to access some resources, in particular port 211, so we can allow the access. And now our DataSnap server is running down here, and it's ready for client applications to talk to it. The next thing we'll do is we'll add to our project group a new project. And this is going to be a Delphi FireMonkey mobile application. We'll just create a simple blank application. So here's our client application. Let's save everything again. We'll go to that same folder where we put our DataSnap server. We'll put down a T-SQL connection component, and we'll set its driver to be DataSnap. And we can look at the parameters, and it'll tell us that it's talking via port 211 and localhost. We'll turn off login prompt because we don't have any kind of authorization or authentication for our application. So let's see if we can connect, and sure enough, we can check the checkbox connected. And since our DataSnap server is running on the same machine as our IDE, we can connect to it. And then we'll put down an edit box, and that's where we can key in the string that we want to send to our DataSnap server. We'll put down two buttons, and this first button is going to be our echo button, and we'll just set its text property to echo. And we'll put a second button down, and we'll give it the name reverse button. The next step is we need to generate the DataSnap client classes so that our mobile client can get to the methods over on the DataSnap server. We do this by right mouse clicking on the SQL connection component and choosing the generate DataSnap client classes. This uses the proxy generator that's built into the DataSnap server that gives us our client-side interfaces that define the echo string and the reverse string and the parameter types and the return. And then it gives us a nice way to call via the server methods. Each of those methods does all the setup of the DBX connection. We can save this out to our client application. And back on our client application, we need to use that unit. So we can go over here and say use unit, the proxy unit, so that our main form unit knows how to get to those methods. We'll add one more component to our user interface, and this will be a T-label component that will contain the output of the remote server methods to either echo the string that we type in or reverse the string. So we'll just leave that down here at the bottom. So I'll add a T-switch to our application, and we'll use the switch to turn on and off the connection from our mobile client to our DataSnap server. I also need to go into our SQL connection component and change localhost in our mobile client application to be the TCP IP address of the machine where our DataSnap server is running. In this case, it's on my local network. And then for the implementation of the echo button, we'll create a variable which is going to be my server class, and it's going to be the type of my server method client, which was generated over here in the proxy. And then in the body of the event handler for echo button click, we'll say my server class : that server methods client. We'll call create, and we'll pass it the SQL connection DBX connection command. After that, we can simply call my server class.echoString, passing it the text from the edit box and taking the result that comes back from our DataSnap server and placing it in the label one's text property. And then we'll free up the server class. We can do the same thing for our reverse button. Double click, and we can take the code from up here, use the instance variable, and then let's go and create the connection to my server class over in the DataSnap server. In this case, we want to say label1.text is going to get my server class dot reverse string is the method. So we notice we have code insight. So reverse string, and we're going to pass that the value, which is a string. We'll pass this edit1.text just as we did before, and then we'll free up the server class because we're finished with it. We can save all of this. Now what we'll do is we'll run our DataSnap mobile client. Remember, the DataSnap server is running down here, and we'll target the iOS simulator. We could also target the physical device, an iPhone, iPad, whatever. We'll just use the simulator for this quick sample. We'll go and run this application. Now it's compiling it and deploying it over to my Macintosh desktop. I've got my PA server running here, which is letting the IDE communicate from the Windows IDE to the Mac. We'll turn on our connection and put in a string, hello world, and then we'll call echo, and we get our result back. So it's made the call from our iOS mobile client into our DataSnap server running on Windows, passing it the string from the edit box and returning it back. Same thing with reverse string. We call the reverse string method in our DataSnap server, and the result that comes back is hello world backwards. Just to show you, if you aren't connected, you'll get an error that says the connection cannot be nil. Make sure the connection has been opened with an OK, a default error message. We could also put a try block, of course, around our call to the DataSnap server to have a more friendly message to tell the user to turn on the connection. Or we could have the connection automatically turned on when the application runs. So again, coming back here, and we're there. Okay, so that was just a quick look at how to get started in building your first DataSnap server with simple methods using the wizard and building an iOS mobile client that works with it. Now, Pavel is going to show you how to build your first SQL database, DataSnap server, and iOS client that accesses the data and metadata from an Interbase database.
I'm going to create two projects. First, I'm going to create a DataSnap server project that will just expose data from the underlying Interbase database. Okay, let's go. In the DataSnap server, I'm going to create a standalone DataSnap server as a VCL forms application. I'm going to use HTTP protocol. I'm going to select a default port to be 8901. It's always a good idea to see if this port is free. And I'm going to make sure that my server methods class is based on DS server module, because I'm going to expose data from the underlying database using T-dataset provider components. Okay, I'm not going to focus too much on anatomy of a DataSnap server. So basically, I have just a main form before, because I have selected the VCL forms application. I have also a server container unit with some components that were generated by the wizard, and the functionality of my server is actually inside of the server methods class. So I'm not going to write any code, because my server is supposed to expose some data from the underlying database. When you install Delphi XE4 or RADStudio XE4, you will also get an Interbase installed, and also there will be an employee database pre-installed for you. So I'm going to actually focus on this customer data. So in order to do it, probably the easiest thing is to just take this customer node and drag it onto the data module. So this is my employee database and the SQL dataset that is already pointing to the customer database. The last step in implementation of the server is to add a T-dataset provider component to the form. I'm going to actually call it CDS DSP customer, so I know which table it's pointing to. In general case, I could have multiple dataset providers on the form, so it makes sense to give them some meaningful names. I need to hook this dataset provider to my dataset, and in this moment my application is fully functional. So in order to create an iOS client for it, I need to have it running. So instead of running this application locally here in Delphi, I have decided to make it more realistic, and I have deployed it into my cloud. So here inside of AWS, Amazon Web Services, I have an EC2 instance running where I have deployed this application. So notice this is the IP address of my machine, and also the port number is 8901, so that's something I need to know. Another thing is that I can actually remotely connect, so this is actually a remote desktop connection to my machine, and this is this program that is running currently and listening on port HTTP 8901. Okay, so this is my server, so now it's time to create a client for it. So I'm going to create a brand new FireMonkey mobile application. I'm going to go for a just blank application. I need to somehow add functionality to connect to my DataSnap server. The easiest way to do so is to use a wizard. I'm going to use a file new other, and in the DataSnap server category there is a DataSnap client module wizard I can use to conveniently connect to my server. I'm going to select remote server as an option where my server is located. I know that that's a DataSnap standalone server. The protocol to be used is HTTP, and I'm also going to make sure that I have specified a correct address of my server and correct port, which is 8901. So now I can see from inside of the client wizard if I can actually connect to this remote machine. I see that I can connect. So this wizard will add to my client project two new files. I want to be able to connect to the underlying database that is there on the server. So the wizard itself also generated for me a data module with a SQL connection component that is already pre-configured to point to my server. So you can see that things that I have entered into the wizard are already there. The protocol, the port, the host name. Also, conveniently, I don't have a login prompt set, so I can use it directly. So again, this would be the client module that I would call its property server methods one client of the same type as this one type of a client proxy to call methods. But in this demo, I'm just focusing on accessing a database. So here, if I want to access a database, I need to add some components. So the one component I need to add is a TDS provider connection component that needs to be connected to the SQL connection component, and also I need to specify the server class name. If I don't know much about the server, that could be a difficult point. In ideal world, I would see here a combo box, but luckily I can actually find out what is the name from the generated code. So the proxy generator is using this convention that is taking the name of the server methods class and is appending client to it. So I know that this is the actual name of my server methods class, so I can actually conveniently paste it here. Okay, so in the client module I have my DS provider connection component configured, and now I need to add a client dataset component. So the client dataset component needs to be connected to the provider connection through its remote server property, and here I should see the provider names that are actually at the server. So at that moment, at design time, I have connected with the server and queried it method to get me all the names of the providers that are there. So I have only one provider, so this is my DSP customer provider. I can actually now make this active. At this moment, I can actually see data from the server at design time were downloaded into the client dataset. So I can actually name this client dataset so it has some meaningful name, CDS customer. Now I'm ready to actually build user interface for it. So first of all, this is my main form, but I need to add to the users clause of this main form this class where I have all the database access components. So I need to add it to the users clause. So now I see this is added to the users clause. I'm going to add a TTAP control component that will host two tabs. So typically what you do is to align it to the client, and I'm going to add two tabs to it. One tab and a second tab, and I'm going to actually make the tab tab control, so you can control how tabs are displayed. So by default they are tab position top, but in fact I don't want to see this at all, because I'm going to navigate between tabs programmatically. So I'm going on the first tab, I'm going to add to toolbar component, which is a standard component for displaying some header information, and also there's something I'm going to add to the second tab, because there will be different elements on both toolbars, on my first tab and on my second tab. Okay, so that's my first tab. So this tab is going to contain a T list view component. The T list view component is designed for being bound to data sets. It can be a lot of data, so it's scrollable, and I can control the appearance of the list view. I'm going to stick with a default appearance here to make it easy. So I have a list view. In fact, I can actually change it, list view customer, so I know that this is my list view customer. And now I'm actually ready to use visual live bindings to bind this list view to my customer information. So I'm going to select view live bindings designer, and you can see in my designer that I see my list view, and also in different color is a client data set on a client module, but it is visible because I have added it to the users clause. So I'm going to make sure that my list view is synchronized with my underlying client data set, and I'm going to bind the customer field to the item text property, so I can immediately see that my data is actually displayed in the list view. So at design time I can see the information from the underlying table. Okay, so that's my main form. In fact, what I can also do to make it a little bit more interesting, I can use visual live bindings to actually navigate in the underlying data set. For this, I'm going to add two speed buttons to my form. Here I'm going to change the first style of the first button to be something that would suggest that we are going to go down in the underlying data set, and I'm going to actually copy this button because I need two of them, and I'm going to change its icon that would suggest that I'm going up. So actually I can just directly here arrow up tool button. Actually that would not work, so I want to select it from here like this. Okay, so I have two buttons. So how do I connect them to the underlying data set? So I'm going to add a T action list component to the form, and one of the actions that I can actually define are actions to actually navigate in the underlying data set. So you see there are live bindings actions, and I want to select the prior and next action. So I select both of them, click on OK, and I will get these two actions added to my form. So these actions need to be connected to the bind source. So this component was added automatically to my form. So I'm going to select both actions, and they have a property called data source that needs to be connected to the bind source DB. In this way, now I have two actions defined, but I need to hook these actions to my visual component. So this one will go to the next record, and this will go to the prior record. This is kind of okay. So I have first form with just a list of individual customers. What I want to do right now is to actually also define a way to actually display some more information about the currently selected customer. So I'm going to define on the second tab this information. So I'm going to actually put here some controls. I'm going to put a big label component. here on the top. So this will display the current customer. So I'm going to name this customer, so I know that this is the label for displaying customers. It's always a good idea to actually define a style lookup to be this tool label, so it has this look and feel. Also, I want to have here, maybe also it's a good idea to use anchors. So if I have some bigger size of the form, it will use the maximum, occupy maximum space, and I can also add some additional information. So to make it look nice, I'm going to use a listbox component, to display some more specific information about the currently selected customer. So I'm going to make it align to the right as well, so this will nicely show in different orientations. I'm going to add some listbox items to this form, listbox item and listbox item. So let's keep it simple, so just first name, last name and the telephone number. So I'm going to change this listbox item text to first, this is going to be last, and this is going to be my phone. Okay, phone. And I also need to add some labels to actually display this information. So I'm going to add a label component to this first element here, also making it bigger, and add an anchor to the right. And I need more of them, so I'm going to add them to individual listbox items. So I'm using FireMonkey. So in FireMonkey, all components can contain other components. So in this case, I have these labels contained inside of my listbox item. So to make sure that I know which is which, I'm going to name them correctly. So I have label 1, label first, label last, and label, okay, this one is label last, that's correct, and this will be label phone. Okay, so now I'm actually ready to bind these labels to other fields in the underlying data set. So for this, I'm going to go back into the Live Bindings Designer, and he's getting more busy, but I will find out what I want to add. So my label first should be bound to the contact first. My label last should be bound to the label last. My label customer should be bound to the customer field, and my label phone should be bound to my phone number. Okay, so in this case, I've been able to actually connect this data. So the one thing that I'm missing is actually functionality to navigate back and forth from one tab to another. So for this, I'm going to add here a button, speed button, place it somewhere here with a convenient style, so it will suggest that I'm going back. So I can actually use different styles. For example, I can have this back button, but to conserve some space, I'm going to make it like this, so it's quite obvious what it's doing. So in order to navigate between tabs, I'm going to use actions. So here I'm going to define two more actions, a new standard action, and this is a change tab action. So one change tab action and a second change tab action. So I typically like to give them names that suggest where they navigate to. So the first change tab action 1 will be changed to detail. So this is my detail information where this screen will be displayed. So I can actually select this tab, and this will be change tab action list. Okay, so very important is to make sure that it looks nice, that this change tab actions has the transition property set to slide, so I get this nice sliding, and I need to hook those actions to appropriate tabs. So let's make sure that these tabs actually have correct names. So I have a tab item 1 that contains my list view. I'm going to name it tab item list, and this other tab will have a name tab item detail. Okay, so now I can hook those change tab action detail will navigate to this tab item detail, and the change tab action list will navigate to this other. Okay, so now I need to hook these actions to some components. So this is the component to navigate to the list, and on the other screen I'm going to navigate to invoke this action programmatically. So when the end user selects a certain customer, I'm going to navigate programmatically. So in the events here I have actually on item click event that is I'm just going to invoke this other action. The name is change tab action detail and execute target. Okay, you can pass whatever, for example self. The one thing that I have used in this data module is a client dataset, and the client dataset requires additional library to be deployed to the target machine. So in the project deployment, I have different lists of different files that are being deployed to the client, and I need to add to it also the Midas library. So this is, if I open it, I can see that this is actually the lib Midas dilib additional file that needs to be deployed. So now I should be actually ready to deploy my application correctly. So click on run. That's my application. So notice that I'm at the beginning of the data set, so this prior button is disabled because there is no point in moving. I can actually navigate through the individual customers. If I click on a individual customer, I can see the detailed information about this customer. I can go back, click on some other customer, and in this way I was able to very quickly build a client for displaying information from the underlying database.
That was great, Pavel. And now Al is going to show how you can build a DataSnap client application for mobile that talks to a chat server that's built using DataSnap.
In here, we have this chat application similar to the GoToWebinar chat window that you're using to send messages back and forth. And inside of it, we have business logic that knows how to get the user list, it knows how to send messages, and it knows how to send messages to an individual user. So we took these methods, we stuck it inside a DataSnap service. The DataSnap service is this. If I start it up, it's a simple lightweight Windows executable. This is running inside an Amazon EC2 cloud. So this DataSnap service you have here with those methods inside of it are sitting inside an Amazon EC2 cloud. And then the front-end client that we created as a Delphi FireMonkey iOS application is this. And what's going to be cool about this is this will be able to connect. So if we see where it's actually connecting to, so this is the Amazon EC2 cloud instance, that's IP address, and that's the port we're listening on. So if I now connect to this, give it my name, let's give myself Al_iOS. And when I say go connect and log on, it's connecting to that Amazon EC2 cloud, that DataSnap service. It's calling those business methods we have up there, and I get the user list here. So this is all really cool. So we have a separate tab for chat window, individual users. So if I want to pick an individual user and send that individual user a chat, I can do that.
Thanks, Al, for that overview on using DataSnap in the cloud with the FireChat app. Now, can you tell us about DataSnap mobile connectors?
Thanks, David. So what are DataSnap mobile connectors? Well, DataSnap mobile connectors is just another name for a generated proxy, but there is a little bit more to them. The essential part is a mobile connector is just a generated proxy that runs on a mobile device. So if you've used other DataSnap proxies in the past, like if you have a JavaScript client, and you can generate the JavaScript proxy. It just generates a file. And the file has a mapping to all the server classes on your DataSnap server. And then for each server class, it has a mapping to the methods on the DataSnap server. And then it just allows a really easy way to invoke these methods from your mobile clients. So all you have to do is set up the server class, the proxy server class, give it the host and port of your DataSnap server, and then you just invoke the methods as though they were on the client, and the generated proxy does all of the work, all of the heavy lifting. So your mobile clients using the DataSnap mobile connectors will know how to connect to the DataSnap server, how to send the requests, how to parse the response, and make it look like you're just invoking local methods instead of going to the DataSnap server. So now these mobile connectors do have an extra component for dispatching proxies to the mobile client because, for example, you might be developing the mobile client on another machine, for example. So let's say, for example, you're developing a Java BlackBerry app using a Java Eclipse IDE or a Windows Phone app using C# and Silverlight. So you'll connect to the DataSnap server and generate the proxy so you can use it in your BlackBerry and or your Windows Phone app. So this one extra thing is the main difference between a mobile connector and just a regular DataSnap proxy generator. The first thing to do using RadStudio XE4, either Delphi or C++ Builder, is to create our DataSnap server. And we do that from File, New, Other, DataSnap Server. Now the DataSnap wizards for the DataSnap REST application, DataSnap Server, and DataSnap Web Broker application all have the mobile connector options. For this example, I'm going to select a DataSnap server. I'll use a VCL Forms application. On my server features page for my protocol, I'm going to use HTTP. I'm going to select Server Methods class, and that will give me sample methods I can use in my application. And here, I'm going to select Mobile Connectors. Now, by checking Mobile Connectors, this will add the static files that the generated proxies require to the project, and will also add the Proxy Dispatcher component. Say Next. For my HTTP port, I'll use 8089, test it just to make sure it's free. Yes, it is, correct. Go Next. For my server methods ancestor class, I'll use a T component, and this will give me the simplest code-only implementation. Next. Here on my last page, the project location page, it asks me to set up my project location. So this will be the name of the project. So I'm going to pick a name that makes sense for what this project is going to do. So I'll select a folder to store the project. So now, generated from the wizard, we see our DataSnap Mobile Connector project. And if we go look at our File Explorer, we see that we now have a proxy folder, and this gets generated from the Proxy Mobile Connectors checkbox. And in this proxy folder, we have directories for C# Silverlight, Free Pascal, iOS, Java Android, Java BlackBerry, and Objective-C iOS. So these are the static proxy files that get generated for each of our supported mobile platforms using the DataSnap mobile connectors. So what these static files are, if we look at them, are source files that the generated proxy needs to use. So for example, if we look at Java Android, we see files like REST connection, and we'll use this REST connection to specify the host and the port of the DataSnap server, and then you'll pass the connection to the generated proxy in the constructor, And that's all the mobile client needs to know. And then you have a proxy instance that you can use to call the server methods on. Let me go back into Red Studio and open up Server Container. Here we see we have a Proxy Dispatcher. And looking in the Object Inspector, we see that it sets the root directory to a dot, looking for a directory called Proxy in the same directory that our .exe is running from. And then under the Proxy directory, it's expecting folders with specific names such as Java_Android. Now this Proxy Dispatcher is linked to our HTTP service and a proxy generator. So if I click on the proxy generator, we see that the proxy generator does not need a writer specified. But as you can see, we have 11 different writers to select from. So we have C# Silverlight REST, we have Java BlackBerry REST, we have JavaScript REST, plus these 9 more. So these are used dynamically at runtime. So when you request a specific language, if you specify Java Android, for example, then you want the proxy generated for, then it will set this writer and it will generate the proxy and dispatch it for you. So let's run the DataSnap server. And what this proxy dispatcher does is it intercepts requests for a specific URL type. And that type is of this format: the host and port of our running DataSnap server / proxy and / the mobile type we want. So in this case, the proxy dispatcher will handle any requests that have proxy here instead of DataSnap, and Java_Android is the name of the directory under the proxy folder, and the .zip because I'm requesting a zip file which is going to contain the generated proxy as well as the static proxy files. So I saved the file. Now let's go ahead and look at its content. Looking at the contents, I see I have a Java Android folder, and it contains all of the static proxy files, plus it also has our generated proxy, this dsproxy.java file. So if we look at this dsproxy, we see it has our T server methods 1, and it has our sample methods of echo string and reverse string, because in Rad Studio we chose to generate sample server methods. It created this server methods class, this T server methods 1, with echo string and reverse string, so that's why they're in this proxy. So now we can invoke this proxy, and you'll be able to invoke those server methods remotely. If I go back into Rad Studio and I look at the server containment unit, we see that the wizard has added reference to DataSnap, Java Android, Java BlackBerry, Objective-C iOS, C# Silverlight, and Free Pascal iOS. So it needs to do this so that at runtime the units can be found to add into the proxy generator so that it can figure out which proxy generator to use and then uses it accordingly. So for example, if I requested BlackBerry instead of Android, then it would go to the BlackBerry corresponding proxy generator unit, find the proxy generator there, and use it for BlackBerry. Now a second way to get the proxy files is by running this command line utility called win32 proxy downloader.exe, and it's located in your Rad Studio bin folder. So for example, if I want to get that same Java_Android proxy files I used with the URL, I could do it by using this command line utility, Win32, proxy downloader.exe, give it dash language, the Java _ Android. So that's the name of the directory under the proxy folder. Give it the dash output of where I want the files to go, and I give it the dash host, the host name, and the port of my running DataSnap server. So now let's take a look at how a Java Android mobile app uses the DataSnap mobile connectors to call methods on a DataSnap server and return the results to the mobile app. I created this Java Android mobile app using Java Eclipse with the Android SDK. So it has an edit box and a button. So when I click on this button, I need this app to connect to our DataSnap server, call the reverse string method, pass it the value from the edit box, and return the results to the same edit box. The first thing I need to do is add my DataSnap mobile connector Java _ Android proxy files. So I'm going to use the command line Win32 proxy downloader.exe from my exe4 bin directory to get the Java _ Android proxy files from our DataSnap server. So now my output directory is this source folder for my Android project. So I'll want my proxy files to go to the same directory. So my com.embarcadero.java Android files will get placed under the same source folder. So with my DataSnap server with mobile connectors still running, I'm going to run this Win32 proxy downloader. I'm going to get the Java _ Android proxy files, and I'm going to have the output go into the source folder of my Java Android project. And that's done. So now, if I refresh my Java Android project, I now see that my com.embarcadero.java Android package gets added under my source folder. So that's great. So this com.embarcadero.java Android package, so it includes all the source code, including the proxy file, the ds-proxy.java file. So now I can use the proxy to invoke the DataSnap server reverse string method. Now I know I'm going to be using both the DataSnap REST connection and the DataSnap proxy files, so I'm going to add them to my project. I'm going to import them in here. So I want to import com.embarcadero.java Android, and I'm going to need the ds proxy, and I'm going to call its tserver methods class. I'm also going to use the ds REST connection, so I get that from here. Great, so that's done. In my button onClick method, this is where I want to set the connection to my DataSnap server. So I'll code that by saying DREST connection. I'll call it my connection, and I'll create a new instance of DS REST connection. Next, I'll set the host and the port of my DataSnap server. So using my connection, I want to call it set host. So here I can't use localhost because my mobile device won't know about localhost. It'll know about itself, so I need to give it the actual IP address of where my DataSnap server is running. And in my case, on my box right now, it is this IP address. And next I'm going to set the port. And I have my DataSnap server listening on port 8089. So that's done. Next I'll create an instance of the proxy. And that's my tserver methods 1. I'll call it proxy. and a new instance of tserver methods 1, and I'm going to pass it the connection string. So now that's done. So the last thing I need to do in my try-catch block is to set the text field and call proxy reverse string and pass in the value from the edit box. So I'll do that with edit1 dot set the text, give it my proxy dot reverse string. Its value is going to be the value from my edit box, get text, and I'm going to send that to its toString. And that's done. And just in case anything goes wrong, I'm just going to print out stack trace. So in my app, I already have my edit1 box set to the word Embarcadero. So let's run this app and see what it does. Right click on my project, run as an Android application. Launching my Android application brings up my Android emulator, installs my .apk file, and the application launches. So to set up what we have here, we have our mobile application, we have our remote DataSnap server. So now when I click on this reverse string button, it goes to the DataSnap server, calls the reverse string method, and returns results back to our mobile client. So that's great. So that's how easy it is to call a DataSnap method from a DataSnap server using mobile connectors from a Java Android device in this case. And you can also do the same with Java BlackBerry, Windows Phone with C# and Silverlight, and Objective-C for iOS.
Thanks, Al, for that great look at the mobile connector technology. Now, can you just do one more quick demo and show everyone how easy it is to use HTML5 Builder, which is part of RAD Studio, to build a web application that connects to a DataSnap server? That would be great.
Here we are in HTML5 Builder, and let me show you how to create and use a DataSnap REST client module to access a DataSnap server and call the functions exposed by the DataSnap server. Now for my client, I'm going to use a server web application. Now a server web application is a web application that runs in a web browser, allowing you to use both server-side and client-side web technologies, and has built-in support for database interaction, and AJAX is also provided. It can also be accessed through a web browser from any device. From the main menu, a server web application is accessed from Home, New, HTML5 Builder Projects, Server Web Application. The Server Web Application consists mainly of server pages, often along with server data modules and server units, although they might have any type of file. So now the first step in creating a server web application with HTML5 Builder is designing the user interface. So as we see here, there are many components available by default for creating user interfaces. For my web client, I want to use a label for my title. I'll use an edit box to accept input. I'll use a button to submit my request to the backend DataSnap server, and the results I want to return in this bottom edit box. For all of our components, we can view and change the component's properties by using the Object Inspector. So for our label, let's change its title, and I want the title to be HTML5 Builder DataSnap Web Client. Let's change its font size. Let's go to its font. Instead of 11 pitch, we'll make it 18. And let's all change its color. So for its color, let's make it a nice magenta. Alright, let me resize it so it fits. For the button, let's change its caption. Instead of button 1, let's call it execute, and let's make it a bold font. So for its weight, let's make it bold. For the top edit box, Let me just change its name. So instead of calling it edit 1, I'll just say E for edit, be my input box. And for the bottom, this will be my edit box for my output. Now the next thing I need to do is write a response for our button click. Now for web applications, any response to users' actions, such as button clicks and text field entries, can be implemented as a response to an event. In HTML5 Builder, such responses are referred to as event handlers. Now, for the button component, the most typical event is a button click. So if I was to double click on the button in the designer, HTML5 Builder will create for me the skeleton code to implement an event handler for the button click event. We can now implement responses between the braces. So let's implement the response to pass the value from our top edit input box to the bottom edit output box. So in between the brackets, I'll write some PHP code. First, I'll add some comments on what I want to do. So I want to take in the input from the top edit box, and I want to pass it to the bottom edit box. Alright, so now to do this, I'll write some PHP code. So the first thing I want to get, let me get the text that I put into my top edit box. So we see here in HTML5 Builder, while I'm typing my code, I get some hints indicating the kind of parameter you need to specify appearing. Also, hints will indicate the kinds of members that are supported in a given object, that is, the properties and methods of our components. So I want to grab our top edit input box. I want to get its text. So now that I have that, I want to set the text from the top edit input box to be the text in my bottom output text box. So now I need the bottom edit box, the output box, and I want to set its text to be equal to the text from the top edit input box. So that will do that for me. So our implementation for this application is now finished. So now we can go ahead and execute our application. So let me switch from the code view back to the design view. So I want to run our application. So to run our application, I can either pick run without debugging, or I can say run with debugging, or simply press F9. So once we have executed the application, the web page gets loaded on our default web browser. If we enter text on the top and hit our execute button, we see that the text that we entered in the top edit box gets displayed as text in our bottom edit box. So now that we have a web server application, the next thing we'll do is add our DataSnap REST client module to be able to communicate to our backend DataSnap server. So let me close our web page, go back into HTML5 Builder. So to be able to create a DataSnap REST client module, we do that from Home, New, Other Projects, Other Files, and here we see a DataSnap REST client module. So now a DataSnap REST client module is a data module that lets you access a DataSnap server. You can then include that data module in another data module or a web page to be able to call the functions exposed by the DataSnap server. Now, before we can create this DataSnap REST client module, we need to have a DataSnap server running. So I don't have a DataSnap server running yet. So I'm going to go into Delphi and create a new DataSnap REST application. So here's my DataSnap REST server. Let me open up a browser window to test the functions. So this reverse string function, this is the function that we want to call from our HTML5 Builder web client. To test it here, I'll click reverse string and it returns correctly. Now that we have our DataSnap server started, we can now generate our DataSnap REST client module. On our new DataSnap REST client module dialog, we need to fill in these properties. So for protocol, we're going to use HTTP. For language, we can choose a programming language for the module. It can either be PHP or it can be JavaScript. If we choose PHP, the connection will be set up with rad PHP component library components. Now, if you want it to be generated with pure PHP code, then we'd simply check PHP and generate pure PHP code. For this implementation, we are going to use PHP. For the host where our DataSnap server is running, that's our local host. And when we created the server, we had it listening on port 81. Now, depending on how you have your DataSnap server set up, you also may need to fill in the URL path, content, username, and password if you added security. So for this example we're using here, our DataSnap server, in our case it's Delphi, but it could also be a C++ DataSnap server. It's using HTTP. It's listening on port 81, and its IP address in my case is localhost, and we're going to use PHP as the language, and I'll say OK. Our DataSnap REST client module gets created for us. So we see here 2 files get added to our web server project. So by default, one is called client class unit and the other one is called client module unit. So this module, the client module unit, it contains a DataSnap REST connection component, and this is responsible for the connection with the DataSnap server. It also includes a read method called read server methods, and this returns an instance of the class tServer methods. Now this class is defined in the client class unit file, and it contains the methods on the DataSnap server that we are going to be able to call from our web client. So the client class unit file has all of our DataSnap admin functions, plus also all of our DataSnap server methods functions. So in particular, here's our reverse string function from our DataSnap server that we want to be able to call from our HTML5 builder created web client. And let's do that next. So now let's see what we need to do to be able to call DataSnap methods from our web client. So let's go back to our unit 1, which is our HTML5 builder DataSnap web client. Let me go into its code view. And the first thing I want to do is add our client module unit 1 to this PHP file. So we do that by using this icon, use unit, and I want to add the client module unit 1 to our application, and by doing so we get the required ones, client module unit 1.php. Whenever we want to call a DataSnap method in my code, all I need to do is include a global variable for our client module data module, and then I can call the method from its server methods client property. So let's do that next. In our web client, we are now going to replace the function button one click code with the code needed to display the results of the DataSnap call for the function reverse string to our web client. For my function button one click, the first thing I need to do is to prepare to use the client module data module global variable. So I'll say global, and I want to use the client module, data module 1. I want to be able to call the DataSnap reverse string method, and I want to pass it the input the input field content. And we'll do that by creating a variable called ds, and we will use the client module, data module 1, and from there we have access to the server methods client, and from the server methods client we can call its reverse string, and to the reverse string method we want to pass in the input from our top edit box. Okay, so now we can print the result from DataSnap call to the output edit box. So we can still use this edit box output text, and we're going to set that equal to our ds variable and get its result. Alright, so that should do it. So just to repeat what we're doing here, so we are calling the reverse string function from a DataSnap server. The value in our top edit box is our input, and the results are going to get displayed on the bottom edit box. Let's now run our application, and let's see if we can get a DataSnap Web Client to talk through the DataSnap REST Client module to access a Delphi DataSnap server and call the functions exposed by the Delphi DataSnap server. So I'm going to switch from the code view back to the design view. So once again we're going to use this HTML5 Builder DataSnap Web Client. This time when we click the execute button, it's going to use the DataSnap REST Client module to access a Delphi DataSnap server and call the functions exposed by the Delphi DataSnap server. So I'm going to go ahead and run. I should bring up our page in a web browser. I'm going to enter for input Embarcadero. I will click the execute button. It should go through our DataSnap REST Client module and access our backend DataSnap server, call the reverse string function, and return results to our bottom edit box. Wonderful. So that worked beautiful.
And thanks, Al, for that one final demo. Just want to give you a few links for additional examples and tutorials and help information that's available on the Doc Wiki. There is a great iOS tutorial showing you how to connect to an enterprise database from an iOS client application. Pavel Glavatsky has a whole series of tutorials in his Delphi Labs for DataSnap. And finally, Pavel has a great Code Rage mobile session replay. Create iOS applications that work with enterprise web services and multi-tier architectures that you can watch on YouTube, and you can also download the MP4 replay of that session. Well, everyone, congratulations. That's it. You've made it through 6 lessons in how to build iOS client applications with Delphi XE4, how to use the power of styles, how to use the components, how to access local storage, how to build and connect to SOAP servers and JSON servers, and the power of XML. And now you've seen in this final lesson how you can take all of what you've learned and add powerful multi-tier application development using the DataSnap technology. All the replays are available on streaming.embarcadero.com. And all the slides and other resource links are available there as well. If you missed any lessons or if you need to go back and review some of the capabilities, all the lessons are there for you to have. It's time now for Q&A on this final lesson, and we welcome your questions.